So let's start the class today. Good evening, everyone, wherever you are in this entire world. This is the fifth meeting of our course today, the fifth class. Let's say, it's not a meeting, it's a class. And yes, we're running this course just like we do it in school. There are assignments, there are lectures, there are speakers, and attendance. Yes. So thank you very much for keeping your patience over the last 5 days. We have 25 more days to go, 25 more topics to talk about, and maybe even beyond that, we will have some more complimentary session. And I'm hoping you are enjoying your assignments and your homework and challenges that we have given to you. And I'm going through all your work, and it's like really amazing. Thank you so much for it. Today, we have a very interesting speaker from World Food Program. His name is Michael Manalili, and he will be talking about his experiences in using drones for flood monitoring and modeling. So let's start without any further delay so that we have more time to ask questions at the end. Michael, I would like you to start presenting, please. Michael, can we hear you? Hello, Michael. Can you hear us?
Hello, yes, I can hear
Yes,
you.
please. So it's all yours now. The class is yours.
Yeah. So before I start, I would like to thank Dr. Ruchi for giving me this opportunity to present. It's an honor to be here. So I would like to request everybody to turn off your video so that the bandwidth will be decreased, because I will be showing very high resolution images, so that it will pop up on your screen instantly. But if you have questions, just type them down, and we will answer them later. So if my sound is okay, then I can maybe start. So I'm gonna share my screen now. Can you tell me if you see my screen? Can anybody say yes?
Yes, you're visible.
Are you seeing my first slide? Okay. Yeah, so I just would like to give a very short introduction of myself. I am Michael. I am from the Philippines, and I've been working with the United Nations World Food Program for the last 2.5 years. And now I will be presenting to you some of the projects or work that we've been doing related to drones. So the title of my presentation is Drones for Humanitarian Application, Flood Preparedness and Response. Just a quick introduction of our organization. So the World Food Program is the world's largest humanitarian organization that we are delivering food assistance to the hungry, poor, and mostly vulnerable people that are hit by natural disasters and conflict. We do that, and we work on almost 80 countries, as you can see in the map. And the ones in red are countries that are currently have emergencies, meaning they are in a war, or they have droughts, or they have floodings and all that. So it makes it more complicated to respond to emergencies if you have a complex emergency, no? So if I move my slides, does it instantly change, or you have to wait for it to come up?
It changes instantly.
Okay, so that's good. So this is the hunger map that we made last year. So as you can see from here, we are feeding at least 821 million people around the globe. That includes my own country. We are assisting different types of people, especially those who are struck or hit by natural disasters. For example, what happened just recently on Bangladesh and India, we are already responding to those individuals. and then we are reaching them by all means. I mean, by all means, I mean literally all means, by helicopter, by airplane, by providing them airdrops. So this is the airdrop. I mean, we fly the plane, and then we package the food in the parachute, and then we send them down. We only do this if the area is very remotely and we cannot access it, and then if there are rebels on the ground and we cannot pass by land. So we do this type of things, and then we also deliver in cold countries like Afghanistan, Yemen, in different parts of the world, in Nepal, and in areas that are hit by floods. We also use this type amphibious. It can travel on land, both land and water, just to deliver food. You can carry here 1,000 tons of food. So let me go directly to the application of drones to natural disasters. So okay, so before I begin, this project is in partnership with the European Commission, Civil Protection and Humanitarian Aid, and our organization, the World Food Programme, and the INGC. This is the disaster management organization in Mozambique. This was done in Mozambique. The title of the project is the Congo River Flood Modeling Using Unmanned Aerial Systems. So this is the area that we surveyed. So basically, it is in Mozambique, and we studied this very large river basin that is frequently flooded. So as you can see, these are the flight locations that we've flown, and these are the numbers. We did 235 flight missions, 58 hours of total flight time, covered 158 square kilometers, which produced 645 gigabytes of raw data and around 300,000 photos with a team of 12, with 4 persons per team. So these are all the locations of the area that we fly. So this is the drone survey team. I am just right here. And then we used 12 drone fleet and 4 high-end computers and 4 teams of 3 members each. So the other members are not here. They are having lunch during the time. So since we are talking about floods, we used for all you know, there are 3 drone types now. So there is a recreational grade drone, there is a mapping grade drone, and there is survey grade drone. And this one highlighted here is the one we used because they are this is in increasing horizontal and vertical accuracy, because if we are talking about floods, it is very important that the vertical is correct, because floods are 3D. It's not a 2D thing. It's water. It flows. So, and then the hydrologist says that floods kills, what's killing people during flood is the depth. It's not the extent of the flood. Okay, you can have a very wide flooding in that area, but it's only knee deep. But you can have a very localized flooding, but it's very deep, which kills people. So it's very, very important that we use a survey grade drone, which has a RTK, or the real-time kinematic, or PPK, or the post-processing kinematic. I will explain you more in detail later why we chose this type of model for this particular exercise. So the UAV-based geospatial products that we derive in that area is the digital elevation model that we used for generating the flood hazard, and then the oblique photo and video, which we took using a recreational drone, because we also have a use case for that. And we developed the orthomosaic to delineate the houses in a more updated way. Okay, so this is the area where we did the survey. So as you can see, this is a very huge river, no? And this is the analysis area, the red outline. Okay, so what we did is to do a flight plan on this area for 4 days with several flights and teams. And then until we covered this area, we were able to generate a very high resolution digital elevation model, 3 centimeter resolution per pixel, which we used for the modeling. And not only that, it's very high resolution and vertical. The horizontal resolution is, the vertical resolution also is very accurate. By mean accurate, it is 0.5 meters plus or minus. So the error of the model is about 1 meter. But if you don't use this type of drone, if you don't use this type of drone, you can get an error of 5 meters. The implication of that is that if you say that you will get flooded and your error is 5 meters, so you will say the flooding in your area could be between 5 to 10 meters, which is a lot of difference, no? 5 meters of water. But if you have an error of vertical of 1 meter only, you will say your flooding could be between 5 to 6 meters, which is acceptable for hazard modeling. So in this area that we generate the high resolution digital elevation model, we extracted the full width of the river as the baseline, because we need this to understand where is the full bank of the river before it overflows into the community. And then we took a high resolution satellite image to confirm the width of the river. So once we have that, this as the baseline information, we are able to generate the flood hazard model by taking into consideration some hydrologic parameters from the river, like a velocity of the river and the actual stream flow information from the meteorological station. So as you can see, green is a low hazard area, yellow is a moderate hazard area, orange is a high hazard area, and red is extremely high hazard area. But if you can see and overlay that with all the building footprints in the area, you will see that even without the flooding, they are already living in these hazard areas, but they don't know because they haven't experienced that huge flooding event that is supposed to come every 50 years. Okay, so what we did was to validate that information in the field. Those points are actually validation points using mobile data application. So the red dots means that we validated that it is actually an extremely high hazard area, meaning that they experienced flooding there previously. And same goes for yellow and orange and green. So those are the responses of the residents from this random sampling that we did. This is how it looks like in the field validation. We actually measured the level of the water with some survey questions like this one, but it's in Portuguese. If you speak Portuguese, then you will be able to understand some of this one. But it just says that during the 2015 flooding event, how high is the flooding? Is it knee deep, waist deep, chest deep, or above the head? And then we surveyed all those areas. As a result of the survey, as you can see, the color of the buildings changes because we took the hazard value of that building and then classified the buildings based on hazard. So this is what we presented as an initial result of the modeling using the very detailed digital elevation model from the drone. So as you can see, there are many houses that are living in the extremely high hazard area, meaning this should be a no-build zone, meaning no houses should be here, but there are houses actually here. And we did an initial estimation. It's around 1,500 houses in that particular hazard category. And then around 283 for moderate, 159 for 283 for high, 159 for moderate, and 90 for low. And the maximum inundation potentially damage 1.7 kilometers of road and 7 bridges, because there are small bridges here that you will not see. So that is the initial analysis, and they really like the idea because using the very high resolution drone, they were able to generate this flood hazard model, and it's very accurate on the vertical, meaning we were able to do a simulation, which I will show you in a little bit. So at the end of the day, we produced this. Let me just hide this thing. Anyway, so we produced this map and send it to the government. So we did a dynamic flood inundation simulation from the drone digital elevation model, and this is how it looks like. So we simulated all the flooding events that they experience in the area. And as you can see, during the 2015, they experienced a very destructive flooding that actually is agreeing with what we just modeled. So as you can see here, the bridge, you can even see from the model that the bridge doesn't exist because it was broken at the time of the survey. So you can see that this bridge here was this one, and the water is up to here. And it's just amazing that we were able to compute the number of houses based on the model, and it agrees with the data from the government. And you can see from here that the level of the water is actually here. In this, it is beyond the head of this person. And we use this in near real time, meaning to say every time there is a heavy rainfall or a monsoon, we just revise the model. We change only one parameter, which is the depth of the water, and we rerun the model and we generate the results. And it will automatically compute how many buildings will be affected or was affected during that event. But fortunately, during this event, there was none, because the maximum level of the water reach was just 6.9 meters, and the alert level is at around 7.2. So we are lucky here that no houses were destroyed. But we already modeled that the maximum inundation is at 12 meters, and we will expect 1,538 houses to be completely inundated or destroyed. Okay, so we didn't stop there because we know that the drone data is a valuable data. We started thinking about another application of the drone data for floods and waterborne diseases. So I came up with something like this. So if you put a water on that digital elevation model, naturally the water should drain around it. And it could drain in the river or somewhere in the lower elevation. But what we developed is like we try to generate a sink fill, wherein if you put a water on top of the elevation model, as what the rain is doing, it will fill the sinks, and these sinks are actually hotspots for mosquito breeding locations. And then I processed that in the entire digital elevation model, and this is the surprising result. We were able to pinpoint these locations as the potential breeding locations because we know that water is not draining here after a flooding event, which is very interesting. And then what we did is to do a little bit of research. So the Aedes mosquito can fly at around 50 to 150 meters from where it's breeding. So we did a simple buffering of that point. And then after we did a buffer, we tried to intersect it with the number of buildings and did some simple analysis of the potential risk of these residents when it rains and it floods and the water doesn't drain for at least 1 week. They are at risk of having a health issue related to mosquito. And interestingly, those locations are actually seen from the very high resolution satellite image, like this one, also this one, this one. As you can see, they are correctly identified using the simple algorithm that we developed from the high resolution elevation model. Okay, so it's very interesting because we send this data to the World Health Organization, and they are trying to implement the same methodology to a different location to see if there are correlations with the dengue prevalence or occurrence or hotspots. And this could be a very interesting project once we finally have some good results. Okay, I know you have a lot of questions, but I will be skipping through and moving forward. So there is also a machine learning and artificial intelligence and computer vision applications in the same drone data that we collected, because not only we have flooding, we also have typhoon damage on the same area that was flooded. So if the cyclone is very intense and it has a high wind speed, it could not only it will damage, bring damage due to flood, it could also damage properties due to high wind. So we developed something using machine learning. So if this is the drone input, the orthomosaic, we first segment that. So we want to classify this, if these are buildings or not. Once we know that they are buildings and non-buildings, then we classify them as to damaged or not damaged buildings. So basically, we have a training data or labeled image for no damage. We have a training data for damage and the negatives, and then we run a machine learning model to estimate pixel by pixel which are the damaged and non-damaged building using machine learning models. And then this is I developed this one. So we used, because we also have oblique drone videos of the area. While we were surveying, we also took videos of the area. For example, this bridge that collapsed. So what I had in mind is to understand, what if I can count these people here and understand how many people are trapped in this location because the bridge is broken. So what I did is to develop a very simple computer vision model to count the number of people. So what this is doing is that your input video will be splitted into frames, and then that frames it will become a picture. So it will extract the annotated human body on each picture, and it will classify that as a human, and then it will count that. So what that is doing is that if this, as the drone flies over this area towards this direction, it scans this area, and frame by frame it is analyzing this frame of the image. And once it identifies a person like this one, if it passes this red line, the counter will increase. So what this is doing is that the number of green boxes that passes here is actually the number of people that were identified by the drone as it flies. So this is very important for our organization, because initially we wanted to count the number of people that are hungry or trapped in the same location, but we didn't know that this is possible. But now we are testing this in Mozambique, and we have some very promising results. So all this project, like the flood hazard modeling, the machine learning, the computer vision, we presented this in the African Drone Forum this year. These were presented by my colleagues, and this they also showed the drone that we used, and then just for publicity and to get more funds, because we have more applications along the way. So I have few more slides, but the impact of drones in the humanitarian response is very vital, as it gives us information on where to deliver food to the most affected population, because we know already where the the areas that are very vulnerable to flood hazard. And if we know them, we will be able to deliver food like what we did here. We can also use that information to find the best location for temporary shelter or resettlement camps while their houses are still flooded, or we can also use that information to find the best location for them to live. But most of the cases, if you propose to them that this is where you should live, they will come back to where they used to live. So it's a big problem of attitude anyway. So that's why the topic of my slide is drones for humanitarian application, flood preparedness and response, because we can use the drones for the response part like we did, and for preparedness by doing the modeling. By doing the modeling, meaning you can simulate an event on an area that you know that is going to be flooded, and you can already identify the number of buildings that will be impacted. So we took this very nice photo of the people or the kid making a letter of ECHO, because the funding of this project was from ECHO, the European Civil Protection and Humanitarian Aid. So they were really happy that we were doing this for their country and for their area. So this is going to be my last slide. So for me, the real power of drone lies on its application and the impact of that application that brings to human. So even though for maybe some of you are very interested in the technicalities of the drone, I would suggest that you forget that. First, you think of the application. Once you have the application, then you reverse engineer, you understand how it works. I don't think it works the other way around. And if you have questions, I am willing to answer. Thank you.
Thank you so much, Michael. And thank you so much for sharing your knowledge so generously with our class. I request either Amit or Sakshan or both of you to please take over the question and answer session.
Hello, Michael. So this is Amit here. So there are a few questions
Yes.
by the attendants. So the first one is, can we actually say that the drone sees the flood? That is going to happen?
Sorry, can you repeat the question slowly?
She meant that can the drone predict whether the flood is going to happen by the camera feed that you get from there?
No, the actual prediction of the flooding is based on the model from the digital elevation model. So what we're doing is we are actually simulating the flow of the water and the retention of the water by using the high resolution digital elevation model that we derive from the drone data. So it's like you have to process the drone data to derive the actual flood prediction or flood modeling. But the drone itself cannot cannot answer that question. But you have to do some processing and you have to add some hydrological parameters to understand better.
Okay, thanks for the answer. Next question is, can the drone predict the depth of the water?
Yes, that's why I added a slide on the different types of drone. You cannot just use a DJI Phantom drone to do the exact thing that I presented, because the vertical resolution of the DJI drone is about 5 meters, and the 5-meter error is very high. It could be 1 or 2 floor of houses already. So you cannot just go to the community and say you will get flooded at 5 meters when it's actually the error is 5 meters and they didn't get flooded because because of the vertical error of the GPS of the drone that you're using. So these technical things you have to understand first before you implement this very critical project.
Okay, so another question is, what criteria?
Because DJI Phantom drones are considered. Sorry.
Please continue.
Yeah. So because the idea is to generate the high vertical digital elevation model, and DJI Phantom drones are not capable of doing that unless you have a ground control point.
Okay. Another question: what criteria of DEM did you use to know exactly the possible breeding sites?
The criteria is that we put water on the elevation model, and we drain the water for at least 5 days. If the water doesn't drain for 5 days, then it's a potential breeding location, like what we see in the high resolution satellite image, that there is actually water there, even if the flooding has already receded.
Okay, so another question is: what level of accuracy is good enough to estimate the food portions to be deployed?
The level of accuracy of what?
What level of accuracy is good enough to estimate food portions to be deployed?
Okay. The level of accuracy for us
Deploying
for
the food portions.
for it to be called the flood modeling is yeah. So the accuracy should be at least 80%, because if you go lower than that, then you will have a lot of wasted food. So for us, it should be at least 80% accurate, so that we will have less food waste.
Okay, so another question is: can you speak upon RTK and PPK and how it helps?
Yes. So RTK is just, as the name says, real-time kinematics. So while the drone is flying, it's already adjusting the vertical height, and then you get the actual height, not the relative height. PPK is post-processing kinematics, wherein you fly the drone, and then in the post-processing, you apply the adjustment parameters after, while you're doing the mosaic. So it works in a different way. If you want it immediately, or if you want the results to be done on time, you can switch RTK, but it takes more battery and time. But PPK, you can just fly the drone, you take the images, then you post process, and then you adjust the DEM after.
Yes, it's basically the triangulation method that is used to bring the accuracy to centimeter level.
Sorry, I didn't get the question.
No, I was adding to your answer that it is basically the triangulation method by which the accuracy is made till the accuracy is made till the centimeter level.
Yes, you're right, exactly.
Another question is: can you make more clear DJI Phantom drone or EB drone and their applications, like on your
Okay, so
basic topic?
yeah, so for DJI Phantom drones, they are very good for taking oblique photos, and they can be deployed anywhere, vertical takeoff and landing. But we had difficulty for EB, because for EB you have to have an airstrip, like a small airstrip, at least 10 meters, where the drone can land like an airplane. So, but in a more detailed application, I think DJI Phantom 4 is not best suited for this type of application, because first, it's not a survey grade drone, but it's vertical takeoff and landing, which is good. And second, the area that can be covered by a DJI drone is much less than EB, because EB is designed to cover a larger area. Yeah.
Okay, so apart from camera, do you use LiDAR and any other devices sensors?
Yeah, so we already bought a drone LiDAR, but we haven't tested it yet. But once we have that, we will compare that with what we have with the EV result.
Okay. So most of the questions are already answered. If you have any other questions, please. Okay, another question is coming. How did you do that? How the drone can know the depth and slope of topography.
Um, how the drones can know the depth and slope of the topography? Because of the way it works is that it works like a pair of eye. So what it does is that the first image and the second image act as a left and a right eye, and it creates a 3D impression like what we do. For example, your left and your right eye, the reason we are seeing 3D is because it is acting like an eye. So the left image of the drone as it flies and the right and the overlap that it makes is able to do a triangulation, then you will be able to generate the depth of each pixel. That's why you are able to get a height or an elevation from the overlap of the images. That's how we are able to get the elevation, which then we can compute slope and topography.
Okay, another question is what part of your work can be done during preparedness phase?
Preparedness phase, yeah, good question, because for the preparedness phase, if you know that there is an area, for example, it's a resettlement or IDP camp, you want to make sure that they will not get flooded. Because if you invest a lot on infrastructure, on water system, on building the structure, and you don't know that they are at risk of flooding, you will lose more money in repairing that and relocating them by if rather than being prepared by flying a drone, do the analysis, and you're sure that they're not going to be flooded. So for the preparedness, it's better it can be used by that way.
Okay, so which tools of AIML do you commonly use for these applications?
Yes.
Um,
Yeah, I
Another
can see
question,
some questions here.
yes. Can community volunteer participate
Which
in
drone
such
do
a
you
work?
use? Yes. So what we did, especially for the validation of the drone data, is we asked the community to participate using their own mobile phones, and they can all contribute to the survey because it is designed to be shared, so the community can share their experiences, and we can calibrate based on the experiences of the elders that says the water is up to here, not here. Then we do the adjustment later. So it's a good question.
Do you have some kind of local command and coordination center made well in the advance, which necessary tools and
Yes.
teams?
Yes, so we did the coordination in advance with the Air Force of Mozambique because since we are working more with the government, they did the coordination that we are going to fly because we really flew very high, around 200 meters above sea level, and we can easily catch some helicopters there. So we did the coordination that we will be flying in this area. We submitted them our flight plan, and this is the time that we are going to fly and the height of the flight plan, so that they know that we are there, so we will not cause any problems in the area.
Okay. So another question is which organizations are the biggest donors in such kind of projects?
The biggest donors, especially for humanitarian, are the Belgian government. They really like these projects, and the European Commission, they like this a lot, and the Germans. So if you want to get some funding or opportunities, you have to reach these donors. You can easily find them from the internet, and you can submit a proposal. If they find it good and it will serve a larger humanitarian community using your application, for sure they will be happy to fund you. Yeah.
Okay, so another question.
Mm-hmm.
I have a
Yeah,
personal
direct.
question also. So, as you had used drones for detecting a mosquito breeding grounds and all, So similar kind of project I had done, but using hyperspectral cameras, where we used to study like the damp areas, and we used to monitor those areas. So can it be merged with the project that you did?
Yeah. I think there are many approaches of doing that, but it's good that, for example, if there is a methodology that works for this area and there is a methodology that works for the area, and maybe we can combine that to see if we can develop a single model that works everywhere. That is the greatest idea that we could have, and we can immediately contact WHO saying that we have a working model that works on different kinds of topography, and maybe you can help us connect the right people, the right donor, and have something.
Okay, thanks.
Yes. Yes. It can either work real time or post processing, because we were contacted by the Germans. They proposed to us that we can actually insert a GPU inside the drone. It's like it's as big as a credit card that you add into the drone. You can put it externally, and it acts as a GPU, and it can run the machine learning model as it flies. But what I did is to process it when the drone comes back and I have the data. But now there is a possibility to put a GPU on the drone itself, and it will be as real time as it gets.
I have one question, Michael. Following up on the people counter, is it robust enough to handle crowds right now? Because you mentioned the 80% accuracy for deciding the food portions. So is it able to handle crowds like the group of people I was seeing slightly away towards the bridge?
Yeah, actually, that's a good question, because it's very difficult to get the 80%. Because if I am the manager and I say I have a warehouse which can accommodate 10 tons of biscuits or corn, and I say this is the number of people, and imagine 20% of 10 tons is a lot of food that could be delivered. So we have to really reach that. But you have a good point. Sometimes the detector is failing. For example, if there is a person hanging inside the tree, or sometimes the pole, the electric pole has some ear-like features or like a hand, it is being detected as a person. So there are false positive and false negative that we are trying out just to understand, to get the actual persons only. For example, if there is a mother carrying a baby, it doesn't recognize it as a person, because the model identifies a person as a single being only with 2 arms, 2 legs, 1 head. But if you are more than that, it doesn't recognize as a person. So it's adding to the 20% error. So if you have a lot of community with a lot of babies, then your error could be bigger. Then we will have problems with the reporting of the number of food that we need to deliver, and it will impact the organization. So we have to really be optimizing this model.
Are your models and your code like open source on GitHub, and can community contribute to it to improve the detector, for example?
Yes. Actually, since we really don't have time to develop it on our own, we are actually trying to hire a company that could do it for us, because the idea is mine. But since I don't have time to develop, because it's a full-time job, we are trying to different companies to help us develop this model. Maybe we can increase it by more than 80%, which is will save us a lot of money. Yeah.
Sure. If there's a GitHub link, please share that. So if it's an open source,
I will. Yes, I will share.
Thank you.
So there are questions here. Germans, you mean German government or any other entity? I mean the German government. Like, if you know there is a website where you can find all the donors, and if you go to the website of WFP, you can see there all the donors that have donated the WFP and their actual organizations, if they are the German government or a private entity from the German government. It's all in the website. Yeah.
Okay, so there was another prior question to this about bathymetry. So would a bathymetry survey of the area help to reduce the flood or maybe access it in a better way?
Actually, for this type of flood modeling to work perfectly, the best condition should be the level of water should be very low, because if it has a water, then you will have problems getting the elevation because it's not a water penetrating sensor. So you have to survey during summer where you can actually see the riverbed, and it's best that you measure it during that time because also the vegetation is losing some of their leaves, so it's not very green, the vegetation, so you can actually see some terrain from the trees. So because the more soil or reflectance from the soil you get, the better, because you are sure that it is the ground. But if you have more vegetation, grasses, then it would affect the modeling because you are actually getting the elevation, or you could potentially get the elevation of the vegetation and not the ground based on the reflectance of the images that you get.
Okay, so there is a question for me. What purpose did you use hyperspectral sensors in the flood area? Actually, it was not a flood area. Rather, it was the area where waterlogging was taking place in the lower lying areas. So the hyperspectral image was actually pasted upon a normal image on a satellite image, and then we estimated the areas that used to be damp. So we estimated the waterlogging areas and then tried to clear the logging from there.
Mm-hmm. Nice. Yeah. Mm-hmm. I'm not. I'm not really sure if
There
that
are
exists
water
already, but
penetrating sensors, but they are not very accurate. They actually work on a buoy that you leave on the surface of water, and then your drone actually uses like multi what is that, a multi substantial lidar. Sorry, multi substantial sonar to do it, but it is not a very accurate method to do it.
mm-hmm. Yeah. Yeah. Mm-hmm. Yeah. Yeah. Thanks for listening, and I hope you stay in touch. If you are interested in any project, or if you want some more information on the presentation, it's very short, 15 minutes. But if I can share you the details, I would be happy to talk bilaterally. And you have my email in the Google class. Thank you.